Okay, for some reason the voice did not record, so I'm going to do a voiceover just for the first two parts of this question. Hope it doesn't sound too weird. Alright, so we're doing worksheet number 2, which is functions. Question number 1, which is fx is equals to 3 over x plus 2, gx equals 8x minus 5, and hx equals x square plus 6. So for part A, we have to find g 1 by 4. For that, in gx, instead of x, we write 1 by 4, and this would give us the answer. So we write 8 1 by 4 minus 5. So this would give us minus 3. Simply cancel 8 and 4 and you'll get 2, and then 2 minus 5 would give us minus 3. Part B says find f(f)(2). So for that we find f2 first. f2 means in function fx change x to 2. So we write 3 over 2 plus 2, which gives us 3 over 4. So now f(f)(2) actually becomes f3 by 4. So now in the function fx, we'll replace x with 3 by 4, or just simplify it a little. So simplify this and get the final answer. Take LCM here. 4 2s are 8, 8 plus 3 11, and then this is 3 divided by 11 over 4. Flip the fraction and we get 3 times 4 over 11, which gives 12 over 11. This is part B. Alright. For part C, find GGX. GGX. So inside G, we have to write G again, which was 8x minus 5. So just like G1 means instead of 1, instead of x, substitute 1. So here G bracket 8x minus 5 means that instead of x, substitute this whole thing, 8x minus 5. So in gx, instead of x, I will write 8x minus 5. So I had 8, I'll write 8, then I'll write 8x minus 5 instead of x, and then I'll write this minus 5. So I get 64x minus 40 minus 5, which gives me 64x minus 45. Part D, find G inverse x. For that we simply first write y is equals to 8x minus 5, then make x the subject, so this becomes y plus 5 over 8 is equals to x. This is your answer of G inverse x. This is the answer of G inverse x. Just change y to x, and this is the answer for G inverse x. Part E, write gx minus fx as a single fraction in its simplest form. So gx 8x minus 5 minus fx, so minus 3 over x plus 2. Take LCM, we get x plus 2, and then 8x minus 5, x plus 2 minus 3, which gives us 8x square plus 16x minus 5x minus 10 minus 3 over x plus 2, which when simplified should give this. This is minus 10. Yes, we'll get this after simplifying the numerator. Alright, next up is part F1. Show that HGX equals 19 simplifies to this. So in H we have to write the expression for Gx. So H is x square plus 2. So instead of x we'll write 8x minus 5. So I'll write 8x minus 5 whole square plus 6. Open this and we'll get a square minus 2ab plus b square plus 6. So we get 64x square minus 80x plus 31. Also equate this to 19 equals 19 equals 19 here as well, and move 19 to the other side and we get 31 minus 19, 12 equals 0. Now take 4 common. So 4 is common, we get 64 divided by 4 is 16x square minus 20x plus 3 equals 0. Next take 4 to the other side, divide it with 0 and we get 0, and hence we've shown the required equation for F1. F2, use quadratic formula to solve this equation. So for that, simply apply the quadratic formula on 16x square minus 20 plus 3 equals 0 minus b plus minus b square minus 4ac over 2a. So 20 plus minus under root 400 minus 4 times 16 times 3 gives us 208 divided by 32. So 20 plus under root 208 divided by 32 gives us 0.1756, and the one with the negative sign 20 minus under root 208 divided by 32 gives us 0. I think I used negative again. 20 minus under root 208 divided by 32. Okay, so this was actually 1.0756, which will round off to 1.08, and the other one with the negative sign is 0.17 rounded off answer. Question number 2, part A. Find GH2. So first we'll find H2. For this, in place of x we'll write 2, so we get 9. Next we'll write G9. For that, instead of x here we write 9. So 9 square plus 1, we get 82. Part B says find f inverse of x. For that, write y is equals to fx, then make x the subject, so y plus 2 over 7 is equals to x. This is your answer of f inverse of x, but change y to x. Part C is Gfx equals ax power 4 plus bx square plus c. Find the values of a, b, c. So Gx means that write g and then gx again, x square plus 1. Now here, instead of x, substitute x square plus 1. So I'll write equals x square plus 1 and then plus 1 again, this plus 1 again. Open this with a square plus 2ab plus b square, so a square plus 2ab plus b square plus 1, so x power 4 plus 2x square plus 2. So now a is 4, sorry, a is 1 because we have 1 here, b will be 2 and c will be 2 as well. So a is 1, b is 2 and c is 2 as well. Part D, hfx is equals to 81, we have to find x. So for part D, hfx means h and fx was 7x minus 2. So now instead of x we'll write 7x minus 2. So 3 power 7x minus 2 equals 81. Now this will become 3 power 7x minus 2 and 81 is, I believe, 3 power 4. Yes, 3 power 4. Now we'll equate, since the bases are the same, we'll equate the powers. 7x minus 2 equals 8, which gives us x is equals to oh, that was 4, not 8. This is 4. So solve it and we'll get 6 by 7. Question number 3. Find, part A1 is find HF 8 by 3. So first we'll find f of 8 by 3. For that, in the function fx, replace x with 8 by 3. So this gives us 0. And then now we'll write h0. So now in the function hx, replace x with 0 and we get 1. For a2, we have to find gh minus 2. So let's find h of minus 2 first. In the function h, x, replace x with minus 2 and we get 1 by 4. Next we'll write g of 1 by 4. So in the function gx, replace x with 1 by 4. We will take LCM 10 over 5 by 4, and then we'll get 10 divided by 5 by 4 equals 10 into 5 by 4, sorry 4 by 5, which gives us 8. Part 3 is find G inverse of x. So A3 is find G inverse of x. Write y is equals to gx, so y is equals to x plus 1. Next, make x the subject. For that I would move x plus 1 here and y here, and then subtract 1. So I may take LCM here, so 10 minus y over y. This is the answer, but replace y with x. This is G inverse of x. Part 4 is find f inverse f5. So and this is only for 1 mark. So f inverse and f actually cancel each other out because they're inverse of each other, and we're left with only 5. So that's all you need to do in part 4. Part B, write fx plus gx as a single fraction. So simply fx was 8 minus 3x plus gx is 10 over x plus 1. Take LCM, which is x plus 1. So 8 minus 3x brackets x plus 1 plus 10. Open brackets 8x plus 8 minus 3x square minus 3x plus 10 over x plus 1. Next we get 5x minus 3x square plus 5x plus 18 over x plus 1, which is the answer for part B. Question number 4. Part A 1. We have to find G2. First we have to find G2, which means in the function gx replace x with 2 and we get 5. So here we'll write G5. Now we need G5. So in the function gx replace x with 5 and we get 26. For part 2 we have to write gx plus 2 in the simplest form. So in the function gx replace x with gx plus with x plus 2. So x plus 2 whole square plus 1. Open this, we get a square plus 2ab plus b square plus 1, which makes x square plus 4x plus 5. Part 3, find x when fx equals 7. Fx equals 7 means 2x minus 3 equals 7 means x equals 5. Part 4, find f inverse of x. For that we write y is equals to fx, then make x the subject, and this is the answer. Just change y to x. Part B, hx is equals to x power x. Part 1, calculate h 0.3, which means change x with 0.3. So 0.3 power 0.3 power 0.3 gives us 0.70 rounded off answer. I am getting 0.6968, which means 0.70 correct to 2 decimal place, or I think we should give the answer correct to 3 significant figures, so that should be 0.697. Sorry, 69, yes, 7. Okay. Part 2, hx is equals to 256. We have to find the value of x. So h was x power x equals 256. So all we need to do is use the hit and trial method. X power x means either 2 power 2, but 2 power 2 is not 256. 3 power 3 is not 256 either. You'll notice 4 power 4 is 256, so x equals 4 simply. Use your calculator and try different values of x. Question number 5. Part A, find f minus 3. F of minus 3, simply replace x with minus 3 in the function fx, and we get minus 9 minus 2 minus 11. For part B, find the value of x when fx equals 19. We know fx equals 3x minus 2 equated to 19. So 3x is equals to 21, x equals 7. Part C, find f h2. So first we need to find h2. So in hx, replace x with 2, 3 square becomes 9, and then this becomes f of 9. So we need to find function f, value of function f9. So replace in fx, replace x with 9. So we get 27 minus 2, 25. Part D, find gfx plus fx plus x. Give your answer in its simplified form. So gfx is, in the function g, replace x with fx, and fx was 3x minus 2. Let me write it like this in the first step. Then I have to add fx, then x. So g of 3x minus 2 becomes 3x minus 2 whole square, because in the function g I've replaced x with x square, plus 3x minus 2 plus x, open the brackets, ax square minus 2ab. So 3 times 2 becomes 12x minus 4 plus 3x minus 2 plus x. So 9x square minus 12 plus 3 plus 1 gives us minus 8x, and minus 4, sorry, this should be plus 4. Plus 4 minus 2 will become plus 2. Answer for part D. Part E, find f inverse of x. So simply write y is equals to fx. So y is equals to 3x minus 2. Then add, take 2 to the other side, make x the subject. So this will be the answer. just replace y with x. Question 6. Part A, find f5. So in the function fx, replace x with 5. We get 3 minus 10, which is minus 7. Part B, find gh3. So we'll find h3 first. So in the function hx, replace x with 3. 4 power 3 is 64. Then we'll write g of 64. So in the function gx, replace x with 64 and we get 4 over 64. We may simplify it and write 1 over 16. Okay. Part C, find f inverse of x. So we'll write y is equals to fx. Next, make x the subject. So we get 3 minus y over 2. This would be the answer, but change y to x. 3 minus x over 2. Part D, show that part D, show that hfx equals 64 over 16 power x. So h and fx is 3 minus 2x. Now in hx we will change x to 3x minus 2. So 4 power 3x minus 2. Now we need to simplify this. This would become 4 3x times 4 power minus 2, because we know when the bases are the same the powers get added. So if I have 2 cube times 2, let's say 4, this should become 2 4 5 6 7. So similarly, if I have 2a times 2 minus b, this becomes 2 power a minus b. So I've broken this to this. Similarly, I've broken this into this. So we get this, and for 4 power minus 2, I can write this as 4 3x over 4 power 3x over 16. Now again 4 power 3x can be written as 4 power 3 whole x, which can be written as 64 power I made a mistake here. This was 3 minus 2x. So power 3 minus 2x. I'll have to fix the rest. So then 4 power 3 minus 2x, which can be written as 4 cube times 4 minus 2x. 4 cube is 64 and I am taking 4 power 2x in the denominator, so the negative sign changes into positive sign, and then I can write this as 4 square is 16, 16 power x, and we've shown what was required. Okay, part E. Find the value of x when hx equals g 0.5. So hx is 4 power x equals g 0.5 is 4 over 0.5, which means 4 times 2, which gives us 8. So 4 power x equals 8. Now what should be the power of x so that we get 8? What we can do is write 4 as 2 power 2. So this becomes 2 power 2x. I've changed this 4 to 2 square, and I can change 8 to 2 cube. So now since the bases are same, the powers can be equated. So 2x equals 3. So x equals 1.5. Question number 7. Part A. Find f minus 1. So in fx replace x with minus 1 and we get 3. Part B. Solve the equation. Solving the equation means find the value of the variable. We have to solve this equation. 2 fx is 1 minus 2x equals gx is x plus 4. This becomes 2 minus 4x equals x plus 4. So we get 6. We get 2 minus 4 is minus 2 equals 5x. So minus 2 by 5 equals x. Part C. Gx. So 1 minus 2. No, wait. Let me do another step. So this means gx is x plus 4. So we have to find f of g plus 4. So in the function fx, replace x with x plus 4, which gives us 1 minus 2x minus 8. So minus 2x minus 7. Part D. We have to find h2. So first we'll find h2, which is 2 square plus 1, because in hx we've replaced x with 2, we get 5. So that means we are actually being asked to find h of 5. So in hx replace x with 5 and we get 26. Part E is find f inverse of x. So for that we write y is equals to fx, then make x the subject, so that will become 1 minus y over 2. This is the answer, but change y to x. Part F. Gfx equals 4x square plus px plus q. So we go from left to right. So first we need to find first we need to see what is fx. So fx is 1 minus 2x. So I'm going to change this to 2g 1 minus 2x. Now I'll find g 1 minus 2x first. So in function gx, replace x with 1 minus 2x. So 1 minus 2x plus 4 gives me 5 minus 2x. So this becomes h 5 minus 2x. Now in hx, replace x with 5 minus 2x and this square plus 1. Open this and we get a square minus 2ab plus b square and then plus 1. So this becomes 4x square minus 20x plus 26. So now p is minus 2 and q is 26. This was 6. Question number 8. Part A. Find f minus 3. So in fx, change x to minus 3 and we get 11. Part 2, find G2x. So in Gx, replace x with 2x and we get 14x plus 3. Part B, find Gfx in simplest form, which means we have to find G2x minus 3. So in Gx, replace x with 2x minus 3 plus 3. This will give 14x minus 21 plus 3. So I get 14x. Oh, again there's been a mistake. It was 2 minus 3x, not 3 minus 2x. So this is 3 minus 2x. 3 minus 2x, which gives us 21x. Sorry, 7 3s are 21 minus 14x plus 3. Oh, another mistake. So let's just redo this from scratch. Let's ignore this and do part B here again, hopefully this time with no mistakes. So Gfx has to be written in its simplest form. So G and fx is 2 minus 3x. So in Gx, now I'll change x to 2 minus 3x plus 3. So this becomes 14 minus 21x plus 3, which gives us minus 21x plus 17. Correct answer, thank God. Part C. Find x when 3fx equals 7. So 3fx equals 7. This becomes 6 minus 9x equals 7. This becomes minus 9. Minus 1 equals 9x. So minus 1 over 9 equals x. Part D. Fx plus 4 minus gx equals 0. So f x plus 4 means in fx change x to x plus 4, and minus gx means write minus and then a bigger bracket 7x plus 3 equals 0. So this becomes 2 minus 3x minus 12 minus 7x minus 3 equals 0, which gives us 2 minus 12 is minus 10 and then minus 13 equals 10x. So x equals minus 1.3. Question number 9. Part A. HF2 minus FH1 minus FH1. So let's find this F2 first and then we'll find H1. So F2 equals change in fx, change x to 2. So 2 times 2 plus 1 gives us 5, and similarly for h1 in hx change x to 1. So now the original equation will become h of f2 is 5 plus minus f of h1, and h1 came out to be 3. So now we have to find h5 and then do subtract f3 from it. So for h5 in hx I'll change x to 5 minus for f3 and fx I'll change x to 3. So I get 3 power 5 is 243 minus 7. So 243 minus 7 gives us 263. Part B. Find Gfx, giving your answer in its simplest forms. We have to find g of fx, which means we have to find g of fx was 2x plus 1. Now in gx, replace x with 2x plus 1. So 3 2x plus 1 minus 2, 6x plus 3 minus 2, 6x plus 1. Part C, solve the inequality fx greater than gx. So fx is 2x plus 1 greater than 3x minus 2. This becomes 3 is greater than x. So, or you may write it as x is less than 3. Okay. Part D. Which says part D, solve the equation hx equals 1 by 9. hx is 3 power x equals 1 by 9. 1 by 9 is 1 over 3 square, and which is actually 3 power x equals 3 power minus 2. So x equals minus 2. Part E, find g inverse of x. So write y is equals to gx. Make x the subject. So this is what we get. This is the answer. Just replace y with x. Part F, 5 over fx. fx is 2x plus 1 plus gx, and gx is 3x minus 2. We have to, I believe, change it into a single fraction. So take LCM. We get 2x plus 1, 5 plus 3x minus 2, 2x plus 1. So this becomes, let me clear some space. So 5 plus bracket open 6x square plus 3x minus 4x minus 2 over 2x plus 1, which gives us, I'll open the brackets, I'll get 6x square minus x plus 3 over 2x plus 1. Part G, solve f inverse x equals 4. So, and notice it's for 1 mark only. So, let me clear this. Alright, so for part G, we have to find f inverse of x. We have to solve this. Solving means find the value of x. Now notice we haven't found f inverse of x anywhere in this question, so we won't be writing the answer for this. And there's no need to find f inverse of x first and then trying to solve it, because it's just for 1 mark. So what we'll do instead, write x equals f4. what I've done is simply taken f inverse to the other side. When we take a function to the, when we take inverse function to the other side of the equation, the inverse sign goes away. So we get x is equals to f4. Now we had to find the value of x simply. So x is f4, and to find f4 in fx, change x to 4. So we get change x to 4, so we get 9 here. Question number 10. Part A, find f3 part A1. So simply in fx, change x to 3 and we get 11. For part 2 we have to find G3. So for that, let's find G3 first. In Gx, change x to 3, we get 2 power 3, 8. So this changes into G8. So now again in Gx, change x to 8 and we get 2 power 8, which is 256. Part B, find f inverse of x. So for that, write y is equals to fx, make x the subject. This is the answer. Just change y to x. X minus 5 over 2 is the answer for part B. Part C, find f hx, which means find f hx is 7 minus 3x. So in fx, I'll change x with 7 minus 3x. So this becomes 2, 7 minus 3x plus 5. So I get 14 minus 6x plus 5. So 19 minus 6x. Part D, find the integer values of x which satisfy this. 1 fx less than equal to 9. So 1 fx was 2x plus 5 less than equal to 9. We have to solve this and give integer values of x. Break the inequality. So we get minus 4 and 2x here. So x is greater than minus 2, and here we get 2x is less than equal to 4 and x is less than equal to 2. So combine these two, I am getting x is bigger than minus 2 but less than equal to 2. So the integer values would be the integer values between minus 2 to 2, but we have to include 2 and not minus 2. So we get minus 1, 0, 1 and 2. These 4 are the answers. Minus 1, 4 and 0, 1 and 2. Question number 11. Part A. Find fg1. So find g1 first. In gx, replace x with 1. So we get minus 2 here. So this becomes f minus 2. So in f, change x to minus 2. So we get minus 3. For A2, we have to find Gfx, which means we have to find g of 5x plus 7. And in gx, replace x with 5x plus 7. So we get 4 over 5x plus 4. Part B. No, part 3 first. So A3 is Find g inverse of x, so write y is equals to gx, make x the subject, so I'll take x minus 3 to this side and y to this side, then x is equals to 4 over y plus 3, take LCM, 4 plus 3y over y, this is the answer of g inverse of x. Change x, y to x, 4 plus 3x over x. Part 4 is find f inverse f2, and it's only for 1 mark, and we've discussed before that inverse of a function and the function cancel each other out, and we're only left with 2. Part B, this was A4. Part B, fx equals gx, and we have to derive the given equation. So 5x plus 7 is equals to 4 over x minus 3. Take x minus 3 to the other side, these two get multiplied, equated to 4, open the brackets, 5x square minus 15x plus 7x minus 21 equals 4, 5x square, this becomes minus 8x minus 25 equals 0. We've shown the equation. For the next part, we have to solve this using quadratic formula, because we need to give the answer to correct to 2 decimal places. So we'll use the quadratic formula, minus b plus minus b square minus 4ac over 2a. This becomes 64 plus 4 times 5 times 25, which becomes 564 over 10. So 8 plus under root of this divided by 10, and we get 3.17 is the answer with the positive sign, and with the negative sign we get over 10 minus 1.57, rounded off to 3 significant figures. Question number 12, part 1. Find f4, so that would be 2 times 4 minus 3. We've simply replaced x with 4 in fx, and we get 8 minus 3, 5. For part 2, we have to find f h minus 1. So let's find h minus 1 first, which gives us 3 power minus 1, which is 1 by 3. We've simply, in hx, we've simply replaced x with minus 1. So 3 power minus 1 is actually 1 over 3. And then substitute it back here. So we're actually trying to find f of 1 over 3. So in fx, replace x with 1 over 3. And this would give us 2 by 3 minus 3, so 2 by, take LCM, 2 minus 9, which is minus 7 over 3, rounded off, in a mixed form we get minus 2, 1 by 3. Part 3, find f inverse of x. So y is equals to fx. We write y plus 3 over 2 equals x, and we write f inverse x equals x plus 3 over 2. Final answer in the end. Change the y here to x. Part 4, write f of x in its simplest form. So f x means f of fx, which means in fx replace x with 2x minus 3. So 2x minus 3 minus 3. So we get 4x minus 6 minus 3. So we get 4x minus 9. Part 5. We have to equate these two and show this given equation. So fx is 2x minus 3 equals gx is 1 over x plus 2 plus x plus 1 plus 2. So let's take LCM. In fact, let's take 2 to the other side. So this becomes 2x minus 5 equals 1 over x plus 1. Next, multiply 2x minus 5 x plus 1 equals 1. We get 2x square plus 2x minus 5x plus minus 5 equals 1. This becomes 2x square minus 3x minus 6 equals 0. So we've shown the required equation. For part 6, we have to solve this equation, giving your answer correct to 2 decimal place. This is your hint for using the quadratic formula, because middle term breaking or solving by factorization won't probably work. So minus b plus minus b square minus 4ac over 2a. So we get 3 plus minus under root 9 plus 4 times 2 times 9 plus 4 times 2 times 6, get 57 over 4. With the positive sign we will get 2.64, and with the negative sign we are getting 3 minus under root 57 over 4 minus 1.14, rounded off answer. Right. This was actually part 5, not part 6. 9. This is part 6. Alright. There's some problem in the answer, or in fact typing error or some sort. So this is not part of the question, and this is the answer for part 6. This is the answer for part 6. Question number 13. Part A. Find f, g, half. So first we need to find g half, which means in gx replace x with half. So 1 minus half gives half. So that means we actually need to find f half. So in fx replace x with half. So this x 1 over 2 or 1 over 0.5 is simply 2. Part B. Find g inverse of x. So for that, write y is equals to gx. Make x the subject. This side is the answer, but replace y with x. Part C. Find hgx, giving your answer in simplified most form. So hgx means we have to find h of 1 minus x. And now in hx replace x with x 1 minus x. So 1 minus x whole square plus 1. This becomes a square minus 2ab plus b square plus 1, which gives us x square minus 2x plus 2. Part D. find the value of x when gx equals 7. So 1 minus x equals 7, so x is equals to minus 6. Part E, solve hx equals 3. So hx is x square plus 1 equals 3. This becomes x square equals 2, and take under root on both sides. Just a second, that was x square plus 1 equals 3x. This was 3x. So we need to fix this question a bit. This becomes a quadratic equation with 3 terms. So x square minus 3x plus 1 equals 0. We have to solve this using probably factorization. So let's see how that goes. X square minus 3x plus 1 equals 0. This is x square. Okay, not by factorization. The question says give your answer correct to 2 decimal places. So we need to use quadratic formula. Besides, this can't be done using factorization anyway. So minus b plus minus b square minus 4ac over 2a. So 3 plus minus 9 minus 4 is 5 over 2. Positive answer is 3 plus under root 5 over 2, which is 2.62, and the negative one will be 3 minus under root 5 over 2, which is 0.38 rounded off to 2 significant figures. Next is part F. Kx is its own inverse when k inverse x is equals to kx. Alright, so there is a function which gives the same value for k inverse of x. For each of the function fx, gfx, is this true? So we've already found g inverse of x. So let's check for gx as first. So is gx equals g inverse of x? Yes, it is, because gx was 1 minus x, and when we found g inverse of x in part B, we got the same answer, 1 minus x. So it is true for gx. Let's check for fx now. To find f inverse of x, we'll write y is equals to fx, then make x the subject, we get 1 over y, and again f inverse of x is 1 over x by replacing this with x. So this is also true for fx. Fx equals f inverse of x. Both of them are equals to 1 over x. So now let's try for hx. Let's find h inverse of x first. So y is equals to x square plus 1. When I'll try to make x the subject, I'll get y minus 1 under root plus minus. So no, this is not equals to x square plus 1 even if I change this to y. So f inverse, h inverse x is not equals to hx. So this is only true for hx and gx, where the functions are actually equals to the inverse of the respective functions. Question number 14. Part A, find g half. So in gx, replace x with half and we get 0. Part B, find f(h) minus 1. So first we have to find h of minus 1 in hx. Replace x with minus 1, we get 1 over 3. So this becomes f of 1 by 3. So in fx, change x to 1 by 3 and we get 5. Part C, find g inverse of x. So we write y is equals to gx, make x the subject, we get y plus 1 over 2 equals x. This is the answer. Just change y to x. For part D, we have to find f of fx, which means we have to find f of 3x plus 4, which means in fx we replace x with 3x plus 4. So this becomes 9x plus 12 plus 4, which gives 9x plus 16. Part E, fx whole square equals ax square plus bx plus c. We have to write this in this form. Alright, so 3x plus 4 whole square will be equals to a square plus 2ab plus b square. So this becomes 9x square plus 3 2s are 6, 6 4s are 24, x plus 16. Okay, shown. And part F, h inverse x equals g2. So take h inverse to the other side, and like we've discussed before, when we take inverse to the other side, the h inverse should change into h. Just like in grade 8 we used to do, to find theta, we would take sine to the other side and it would become sine inverse. Similarly, to bring it back, sine inverse will change into sine again. So this would become x equals h g2. Now we know how to solve this. First we'll find g2. g2 is, in gx replace x with 2, which gives us 4. So now we need to find h4. So in fact g2 is not 4, it's 3. 4 minus 1, this is 3. So now we need to find h3. So in hx substitute x equals to 3, so 3 power 3 is 27. Question number 15. Part A, Part A is solve fx is equals g. Once solving means finding the value of the variable. So 2x plus 1 equals g1 means in gx replace x with 1. So we get 5 here, 2x plus 1 equals 5. So x will be equals to 2. Part B, find fh3. So find h3 first. So that would be in hx replace x with 3. So we get 8. So we actually need f8. For that, in fx replace x with 8. So 2x plus 1, we get 70. Part C, f inverse of x. So for that, write y is equals to fx, then make x the subject, then this is your answer, but change y to x. Okay. Part D, write Gfx in its simplest form, which means g of fx was 2x plus 1. Now in gx replace x with 2x plus 1, so 2x plus 1 whole square plus 4, this becomes a square plus 2ab plus b square plus 4, so we get 4x square plus 4x plus 5. Okay, part E is solve h inverse, this is x equals 0.5. So like we've discussed before, check x to the other side, h inverse to the other side, and it becomes h of 0.5. Next we have to find h 0.5, so 2 power 0.5 is the answer, whatever that is. 2 power 0.5 is 1.41, and in fact in radical form we can write it as under root 2 because power half means under root. Alright, part F says 1 over h x equals to 2 power k x, find the value of k. So 1 over h x is 2 power x is equals to 2k x. Bring 2x to the numerator, so we get 2 minus x is equals to 2kx. Since the bases are same, we can equate the power and we're getting k equals minus 1. Question number 16. Part A, find h3. For that, in hx replace x with 3 and we get 8. For part B, we have to find fg 0.5. So let's find g 0.5 first, and we get in gx replace x with 0.5, so 1 over 0.5 is 2, so this becomes f2. So in fx replace x with 2 and we get 3. Part C is find f inverse of x. Simply write y is equals to fx, then make x the subject. We get y plus 1 over 2 is equals x. This is your answer for f inverse of x. Just change y to x. Part D, find f f x in its simplest form. So f of fx is 2x minus 1. So in f, change x to 2x minus 1. We get 4x minus 2 minus 1, which is 4x minus 3. Part E, find fx whole square plus 6, giving your answer in the simplest form. So fx whole square plus 6, which is 2x minus 1 whole square plus 6, which is a square minus 2ab plus b square plus 6, which will give us this right here, the answer. Alright, part F. Which of the statements hold true? F inverse of x equals fx. We found f inverse of x in part C, and is this equals to fx? No, it's not. Is g inverse of x equals to gx? Now let's check for the other two functions. Let's check for gx and g inverse of x. We know gx is 1 by x, so let's quickly find g inverse of x, and we can tell from right here that g inverse of x, when we'll make x the subject, it will be the same. So and then we'll change y to x, and gx and g inverse of x are the same, so it'll hold true for gx. And what about hx? To find h inverse of x, we'll write y is equals to 2x. Now there's no way we can make y the subject from what we've learned so far, so we're unable to make y the subject here, so it does not hold true for h inverse of x. So it's only correct for function gx. Part h, use two of the functions gfx, gx and hx to find the composite function, which is equals to, this is actually 2x plus 1 minus 1. So we need to use some combination of functions so that we get 2 power x minus plus 1 minus 1. Composite function is a function like this, multiple functions combined together. So let's see how can I get to this given function. So look, we have fx is equals to 2x plus 1, and I need to change this into 2 power x plus 1 minus 1. So what can be done? So we can tell that the base function would be fx. We're trying to insert something in fx so that we get 2 power x plus 1 minus 1, because fx already has 2 and it has minus 1 as well. So the first function would be 2. Now what can we insert in this? Let's try to insert hx in it, and let's see if we get this desired result. So if I try to insert hx in function f, that means I'll have to write it in this form. So now in fx I'll replace x with 2 power x minus 1. This is 2 power 1 times 2 power x minus 1, which becomes 2 power x plus 1 minus 1. Yes, it's correct. So that means the required composite function is fhx. Question number 17, which part A says, use your graph to find f1. So we can't just substitute 1 in the given equation because the question has bound us to use the graph. So find f1 using the graph. So 1 is the value of x, right? Because fx graph is this. So when x equals to 1, let's read the value or values of y. So when x is 1, I'll draw a straight line at x equals 1 and see where it cuts the graph. So it's cutting the graph somewhere over here. So read this value and you should get something around this given value, minus 3. So the answer should be around minus 3. Alright, next up is find, so y equals minus 3 or just minus 3. Alright, next is find f minus 2, f minus 2. So let's find f minus 2 first using the graph. So here x equals minus 2. So when x is minus 2, read the corresponding value of y, whatever that is. So let's say it comes around 3. So now we need f3. So now x equals 3. When x is 3, read the value of y and we get a little value over 4, and your answer should be between 6.2 to 6.4. Last question, question 18. Part 1, part A, find f1. So again, for f1, x equals 1. Now in the graph, read the value of y when x equals 1. So it comes out it should come between this range. So any value between minus 1.4 to minus 1.6, depending on what you're getting in your graph. Part B, solve fx equals 3. Again we're bound to use the graph. So fx equals 3, this is the value of y. So when y equals 3, we need to read the value of x. So this is y3, read the corresponding value of x, you should get minus 0.5. So x equals minus 0.5.